Good morning, students. We'll be continuing with the same chapter today, chapter number 2, and the topic that we can start today is equation of motion. For any body moving with uniform acceleration, there is relationship between initial velocity, final velocity, acceleration, distance and time, which I have written in short form. These are the symbols for all the quantities. When you are writing the symbols, this should be written in small letters. So altogether there are three equations of motion. First is V is equal to U plus AT, then S is equal to UT plus half AT square, and third equation is V square is equal to U square plus 2S. So we are going to derive all these equations of motion one by one. We are going to start with V is equal to U plus AT first. So we are going to use the graphical method to derive the first equation of motion, that is V is equal to U plus AT. For this you have to draw a velocity time graph. You can see I have drawn a velocity time graph where I have marked this as the initial velocity U, this final velocity V, and this is time t. So we know that whenever a body moves with uniform acceleration, the graph will be a slope. So you have to take this slope so that it represents final velocity in the y-axis and time in the x-axis. Now you can join and you can give name to all these vertex like A, B, C, D and E. I have named this. Let us now see using this graph how can this be derived. You know, in a velocity time graph, the slope AB represents the uniform acceleration. So we can write acceleration is equal to slope AB. And the value of slope AB can be found by taking this perpendicular divided by the base AC. That is, we can write BC upon AC. BC can be further written as BD minus CD. This BC can be written as BD minus CD. So we can write the same BD minus CD. And AC can be equal to DE. Now let us put all the values of acceleration can be A, BD value can be taken as V minus 0, which is equal to V. CD is equal to U minus 0, which is equal to U, and DE you can see it is T minus 0, which is equal to T. Further we can write V minus U is equal to AT, which implies that V is equal to U plus AT. This is the first derivation. We have derived the first equation of motion. So now coming to the second equation of motion, we can use the same graph for it. Now you can see this graph is velocity time graph, and you know the distance traveled using velocity time graph can be found by finding the area of the enclosed figure. So here the area or the figure is ABDE, which is a trapezium. So we can write area of trapezium ABDE. This whole figure you can see is the trapezium. It can be split into two small figures, that is triangle and rectangle. That is, on adding rectangle and triangle we can get area of trapezium. Now area of rectangle ACDE can be written as length into breadth, which is DE into CD. Same as triangle can be half into base into height. Here height is BC and the base is AC. Let us now put the values of each of these sides. DE is equal to t and CD will be equal to u. So we can write t into u half into AC. AC is equal to t, means AC is equal to d, which is value will be t, and BC can be written as V minus u. BC can be VD and V minus u. Further we can write this V can be written as u plus AT, because we have already derived V is equal to u plus AT as the first equation of motion, minus u. Cancelling this u, we can write ut plus half t into AT will give AT square, and distance can be written as s. This distance can be written as s. So we got the second equation of motion, s is equal to ut plus half AT square. Now coming to the third equation of motion, v square is equal to u square plus 2s. We'll be using the same figure and the formula is also same. Distance is equal to area of trapezium ABDE. Now this time we are not going to split the trapezium into triangle and rectangle. Instead we'll be carrying on with the trapezium only. And you know the formula of trapezium is half into sum of parallel sides into height. You can see the parallel sides here is AE and BD. You can add these two, and the height for the trapezium can be taken as DE. Let us now put the values. AE will be equal to u minus 0 u, and BD can be equal to v minus 0, which is v. DE, you can see it is equal to t minus 0, which is t. So if you see the third equation, you don't find anywhere t here. That is, time is not used here. So we are going to replace the value of t using the equation of motion A equal to v minus u by t. So t can be written as v minus u by A. So this t can be replaced by this value v minus u by A. Now you know v plus u and v minus u. We have the formula a plus b into a minus b is equal to a square minus b square. Same way we can now write v square minus u square by a, and this side it is s. You can take this 2 into a to this side, and you will be getting v square minus u square is equal to 2as, which implies that v square equal to u square plus 2as. This is the third equation of motion. So your homework for today will be to practice all this derivation using the graphical method. I will show you another method to derive this equation of motion. Thank you.